All right, let's talk about logarithms for the first time, okay? Logarithms, front and back page, I have nothing to do, but I try to summarize all information for you on front and back pages. So this is just a handout for you. Logarithms, what is logarithm? Have you heard about word log? I saw a big truck carrying lots of trees, and it says, "Caution, logs." And I was laughing while I'm driving. Wow, that's the log. I need to use that example. That's not the log here, okay? When we say log, that means logarithms. And this is inverse relation of exponential function. What does that mean? And we'll talk about further meaning in the future. And let's talk about notations first, okay? If you are looking at your calculator, you have LOG button, right? On the calculator. That is the same thing, and I write LOG with cursive letter like that in class. So when we write LOG with the base 3, 9, and that means what power do I need to raise 3 to get 9? That's the meaning. So in other words, I can consider writing 3 to the second power is 9. So we are talking about answer as number 2 because I need to raise power of 2. We get 9. So that is the meaning, okay? So we write this way. That means what's the exponent or what's the power? That's the question, okay? And that is the notation. So we are learning new notation for exponent. And we'd like to use this as a function notation. So you can consider f as a function, g, h, like that, okay? We write f of x, g of x, h of x, function notation. And now we have logarithm as name as a function. So you use calculator, and automatically calculator is open parenthesis. That means log is a function, okay, log x. And if we are programming, and instead of using y equals e to the x form, and we are using exp as a name of the function or name of the command on the programming, and that is also a function, exp parenthesis x. Sometimes we write that way, but in math writing we use exponential form, not like that, okay? But you will see some programming use exp as function like that. And in pre-calculus class, we will understand sine, cosine, tangent as a function, not only ratio. So when we use this as a function, we have sine parenthesis x, cosine with x. In math class, we usually write sine x like that, without parentheses. Cosine x without parentheses. Log of 9 and without parentheses, okay, like this. That's okay in math writing, but when we use a calculator, we always use parentheses for the input value, okay? So what is input for this logarithmic notation? 9 would be the input value. That's input, and this is the result, which is the output. So that is the meaning of a log. So the meaning of a log is power or exponent. Below LOG button, you can see ln button on the calculator. And ln, I write ln with the cursive L, once again ln, because if I just write that and it looks like 1n, so I write ln with the cursive, log, log with the cursive. Otherwise, it looks like 10g or 109. So I always write first letter L, logarithm, using cursive letter. So ln is a special log because its base is number e. We saw number e the other time when we talk about compound interest. So it is approximately 2.718, and that is number e. And when we use base number e, and we are using natural logarithm, and we will see those in the future, okay? So you can understand taking E and ln, they are inverse to each other. So it is undo process. So you can simply, okay, they are canceling each other, or they are opposite to each other. They are reversing the process each other. So it is undo process. Now we will talk about laws of logs. And on the first day, when we talk about exponential functions, we review middle school stuff, and that was laws of exponents. And it is same thing, okay, because I said logs is the way of saying exponent or power. So the laws are same and meanings are same, but the way of writing is different, because I'm using log, log functions in the writing. So let's think about how we understand this, okay? And what is the operation between A and B? Multiplication. So in multiplication, what do we do with the exponents? Logarithm means exponents. We add them, right? So we add the exponent of A and we add exponent of B. So we are adding exponents. That's how we read this statement. Next one, in division, what do we do with the exponents? We are subtracting exponents. So in other words, we are subtracting logarithms, okay? In the power operation, what do we do with the exponents? We multiply, right? So we multiply n exponent and logarithm together, which is another way of saying exponent. So we multiply exponents, okay? Anything to the 0 power was defined as 1, right? Anything to the 0 power is 1, and now we can inverse this process, and 0 and 1, input output will be swapped, and I can say take 1 for the logarithm function, it will result 0 all the time. So you can see 0, 1 is flipped 1, 0 on the inverse function. Does it make sense? So the meaning is anything to the 0 power is 1. So these are the laws of logs, and we will practice more, and then we will look at this page once again, and you'll understand much better. Next one is called the change of base, and I will mention this. It was a very useful tool when I was learning this, because we didn't have a TI-84 at the time. But now it is very not powerful tool, because you have a calculator. You can type everything and you get answer quickly from TI-84. But in the future, some of you will take calculus class, and you will have some tests without a calculator section, so we will talk about this briefly, so you can understand the way of calculation, how we get answer, okay? Next page, we have graph of logarithm and exponential function. Which is logarithmic function? Oh, we don't know, because this is first day, so let's think about which is exponential function. This is exponential function, right? And the other is called logarithmic function. So this is logarithmic function. They are inverse to each other. How do I know they are inverse to each other? Because they are symmetrical along y equals x. What is the meaning of y equals x? We swap x and y. When we switch x and y variables, this graph, which had horizontal asymptote, goes reverse way, and then we have now vertical asymptote for the logarithmic function. Make sense? So they are inverse to each other. You fold along the dotted line, y equals x, and they are overlapping. That is inverse relation. So we have a lot of notations here, and one way is exponential form, and the other way is written using logarithmic form. Even we are talking about the same properties, same definitions, it can be written different ways based on which form we are using, okay? So let's look at one thing, y equals a to the x power. What is input? What is output here? Input is x, output is y. And can we swap those two things? Yep, and then x will be written as logarithm of same base a with y, and we switch input output, and that is another way to write the same thing with the logarithmic form, okay? And we'll practice those more after that. So we will revisit this after we study lots of properties. And I put fun facts, and the three bases of logarithmics is we are using number 10, number e, and number 2. Number 10, why do we use number 10 a lot? Because human has how many fingers? 10 fingers, that's right. Number e, we haven't seen number e, and we haven't seen those in mathematics or compound interest using finance, so that is very useful. And we can use log with e, and as you see, we have another button on the calculator, natural logarithm, right? So e is commonly used. How about number 2? Why do we have number 2? Okay, 2. Computer programming. What is the number system on it? Turn it on, turn it off, on and off. 2 numbers, right? 0 and 1. What's that called? Binary system, right? So we can use base 2 a lot also. And another application here, okay, chemistry, pH. Have you heard about pH number? To tell acid and bases, okay? And this base is different from this base, okay? We are talking about in math class. So we will see that kind of example in the future while we are doing homework problems, okay? I put some pH problems from textbook, and you will see those, and then you will see, oh, there is a logarithm in pH value. So we can consider that as applications. So that is the fun fact. And let's talk about how we rewrite, okay? So I'm going to do number 1 definition or number 2 definition. That is same kind. So we will do how we rewrite the forms today. So focus thing is you need to be able to find the base. Can you find the base in number 1? 6. Can you find the base in number 2?
2.
Yeah, can you find the base? Yes. How do we find the base? Little number at the bottom, okay, like basement. Okay, little number at the bottom. Number 5, can you find the base? This is exponential form. Can you find the base? 64 is not a little number any longer, right? It's a big number, but we have exponent at the top, so we call this is base, right? Okay, number 6, can you find the base? 12. Can you find the base? Can you find the base? So you need to keep the same base when you write the form. First one is called exponential form, and the second way is logarithmic form. You start with the log, that's logarithmic form. You start without log, okay, that's exponential form. Does it make sense? So we'll rewrite it. While we rewrite, we will swap x and y. Okay? We will swap x and y. So let's rewrite. What is base? 6. What is input? Oh, input was 36 here, right? Output was number 2, and now I need to change the thing. So give me an exponent to write exponential form.
2.
What do I mean exponent? That means power or logarithm. Okay, from the logarithmic form, the result, number 2 is output. Okay, so we want 2 equals to, now I need the output. okay, output by itself. So give me the input from above. Input is with the parenthesis, that is 36. So let me highlight once again. Input 36 goes over here, output. And now this is output. Output became as an input. And I need to still keep the same bases, okay? Bases are same. And we swap input, output, and then that's how we write the new way over this, okay? So with the log, that's called the logarithmic function. Without log, in exponential form, that's exponential form. So it is interchangeable. Sometimes this is easy to solve the equation. Sometimes this is easy to solve the equation. That's why we have two different ways of writings. Make sense? Okay, now let's try number 5. Number 5, what is the base?
64.
So I need to start with new way of writing, log. So I'm going to write cursive log, log. Base is 64, so I'm writing 64 in the lower space here, okay? In the lower subscript. And what is input for this function? Output will be input, right? What was output above?
8.
Number 8 was output, so I'm going to put input. You can put parentheses for the input or not, it doesn't matter. And now let's have output for the logarithmic function. So that is from above, input. Okay, what was the input above?
1.5.
This one is the input, and input will be output now. Okay, so input, output, swap. Here, input, output, swapped. And output, input, swapped. And we are keeping the same base, so we can talk about the same thing, okay? That's how we write exponential form and logarithmic form, and we can rewrite both ways.